In this video clip, we'll see how we are going to draw this rational function. This rational function is x plus 2 over x minus 1. It is clear to notice that when you plug in x equals -2, -2 plus +2 on numerator, you will get 0 for numerator. And then this -2, for sure, x equals -2, we will choose this point. And then denominator, if you plug in 1, denominator will be 0. So definitely 1 cannot be plugged in because the rational function is not defined at 0 point of denominator. So 1 cannot be plugged in. So from here you can see clearly is that -2 definitely we want to plug in, and +1 we are not going to plug in. So that's the impression we get. Okay. Then we may start with -3, which is less than -2. We may choose -4. Okay. Yeah, if we put -4 here, plug in, we'll get 0.4 for y. So that's how we got this point. Okay. Now, -2 again, we want to choose it because you plug in -2 here, you got 0, which is x-intercept. It tells us clearly then the graph will go through the point right here. All right. Now then we may keep going. We may choose x equals -1. You plug in to this rational expression, you get -0.5. That's this point. Okay. Keep going. Yeah. You got a feeling about that. So, we got first one, second one, third one. And then if we keep going, when x is 0, you plug in here is 2 divided by -1. You have -2. So we definitely need this point because that's y-intercept. Keep going one more step. 0.5. X equals 0.5. You plug in, you have a value -0.5. So you mark 0.5, -5 right here. You connect all the points. Now, x equals 0.5 is close to 1. Just now we said we cannot plug in 1 here. Okay? Yeah, because you plug in 1, you get denominator is 0. And the function is not defined because denominator cannot be 0. So when we're not going to choose it, then why not 1.5? So when you plug in 1.5 here, you get y is 7. So then 1.57 is this point. Keep going. X equals 3. You plug in here, you are 2.5. Keep going one more step. You will see x equals 6. And then you have a value, y is 1.6. Basically, you have the graph already. Now you can see here, we chose those very typical points. And we want to talk more about why we need to choose those typical points. Let's see the reason here. You see again 0 point. This is for the numerator. One more time. When x is 1, you get vertical asymptotes. Why? Because when you choose x equals 1.0001, you plug into the expression here. You plug into the expression here and here. You get numerator is approximately just 3. And denominator is very close to 0. Now you can see that. You see 1.0001 minus 1. Denominator is very small, close to 0. And then this makes the whole value very big. Okay, so when x close to value 1 from the right-hand side, you have a very big value y. This very big value y. So that's why when x close to 1 from the right-hand side, you got this value very big outside of this range. So this explains why we have a vertical asymptote when x approaches 1 from the right-hand side. From the left-hand side, you will get very negative, let's say. You may try 2.99999, this value. You will get negative value. So it goes in 2 ways. Positive infinity when x approaches 1 from right-hand side. Negative infinity for y when x approaches 1 from left-hand side. Okay, so that's why we have a vertical asymptote. So 0 point for denominator, you get vertical asymptote. 0 point for numerator, you get x-intercept. For y-intercept is just what? Is just x equals 0. X equals 0. You get y-intercept. 0, negative 2 right here. Okay. So 0 points are very important. One is for numerator. Another is for denominator. Okay. So between this negative 2 and positive 1, that's what I marked here. The graph is actually below the x-axis. X-axis. Let me delete this part. You see, when I click on f of x less than 0, it basically tells you that's this part. That's between 0 point of numerator and 0 point of denominator. Okay, click on that. It gets thicker and then disappear. All right. So let me delete that. You may click on this blue one. Okay. Now let's see how we get the. Again, you may click on that. That's the y-intercept. Now let's see how we got the horizontal. This horizontal asymptote. Okay. For the horizontal asymptote, that's when x gets bigger and bigger. Let's say x choose 1000, that's probably big. And then you can see 1000 you plug in, 1000 you plug in, those values, positive 2 upstairs, negative 1 downstairs, can almost be ignored through this expression. You can see this is the value here is very small. You see the value here? Very small. The value here very small. They can be ignored. That's how you have 1 divided by 1, which is 1. 1x is very big. The value of y approaches 1. Okay? Yeah, you see the general step is right here. 1x is very big. 2 over x can be ignored. 1 over x can also be ignored. Upstairs is just 1 divided by 1. Okay? So you have y approximately is 1. Okay? So this is how we get this horizontal asymptote. Okay? Yeah. Now, if here the coefficient of x were 2, that would be 2x. Right now is 1. If here the coefficient of x is 2, then here would be what? Here would be 2. Then here will be 2 over 1. Here would be 2. But right now here is that the coefficient of this x is 1. So you then get 1 divided by 1. Similarly downstairs, basically 1x goes to infinity, then the value will be the ratio of the two coefficients. One is upstairs for numerator x, the other one is downstairs for denominators. Okay, so basically you click right here, horizontal asymptote, you click on that. Let me click on that. This one disappear. I click one more time. This one shows up. See here, click, disappear, and click, shows up. You may rewind this video lecture, and I hope you will understand more. I'll see you next time.